In this Python tutorial, you're going to learn everything that you need to know to go from zero to something a little bit more than zero in Python. I'm Harry. I've been working in the industry for about 13 years, using Python for pretty much the entirety of it. I specialize in actually building simulations in Python to help companies make multi-million-pound decisions. But we'll save that for another time. If you do want to check out some of my other courses, go to teach'em.digital. But for now, enjoy this one. Step one is setting up the environment. For this tutorial, we're going to use something called Thonny. Now, Thonny is a beginner-friendly IDE that's perfect if you're just getting started and learning Python. It doesn't come with any of the overhead and any of the fluff that some of the bigger software packages come with. It's just super simple. So to install Thonny, go to thonny.org. Download the installer for your operating system. They've got Windows, Mac and Linux options. So now that we have Thonny installed, let's write our first Python script. So open Thonny, you should see a blank editor window. In the editor, type the following code. Print hello world. Once you've typed that, click the run button up here or press F5. Voila, you should see the output hello world down here at the console. Congratulations, you've just written and executed your first Python program. Okay, let's now start with the basics of Python syntax, variables and data types. In Python, you don't need to declare a variable type explicitly. Just assign a value to a variable and then Python will understand the type based on that value. So for example, we can create an age and give it 25 and then we print that. Now if I run my script, I will get 25 in the script. This is an example of an integer. We can check the type with the handy type command. But we can also define a floating point number. Let's define a temperature value and give it 23.5. Then we can print the temperature and we can check that it's a floating point number by printing its type. There we go. So we have our age, 25, which is an integer. We have our temperature, 23.5, which is a float. And there are two basic numerical data types. Now, let's try a string. Name. Let's call our string Alice. Print name. And print type name. Remember, we're using the type just to check what this type of data actually is. And it's telling us that it's a string. Let's try the same now for a list. So, we can create a list with square brackets. And we have to make them equals. We can do a list of anything, but in this example, we'll use numbers. So we'll do 1, 2, 3, 4, 5. Now, if we print our numbers, they will appear down here. And to confirm it's a list, print type numbers. It's a list. So there are some interesting things we can do with lists. For example, we can print just the first value in the list with this command. Numbers, square brackets, 0. This returns 0 being the very first thing in the list. We can return that, and that's from number 1. Now if we want to return the second value, or sorry, the second value, we would use 1. If we want to return the third value, we would use 2. So we can also do dictionaries. Let's define a student and give that student some information with a dictionary. To define a dictionary, use a curly bracket. Let's start by defining his name. So you create a category called name, you use a colon, and then you give it some data. We're going to call this student Bob. Okay, next category. Age. Let's make Bob 22 years old. So now, if I print student, we get information about Bob in dictionary format. But what if we want to access specific parts of this? What if we just want the name or just want the age? We can access this through square brackets after student, and then within that we type name, close the brackets, and there we get Bob. Similarly, we can do the same with age, 22. So Python allows you to perform basic arithmetic operations and use functions to manipulate data. Let's look at some examples. So, some arithmetic operations, we can define two variables. We'll define A and we'll define B. A, we will give a value of 10. B, we will give a value of 3. We can print the sum of A and B. We can print the subtraction. We can do multiplication with the star symbol. We can do division with the slash, forward slash, always a forward slash. And we can do the modulus with the percentage symbol. Let's run this. We get 13, 7, 30, 3.3 recurring, and 1. Okay, great. So now let's go on to control statements using if and for loops. So control flow statements allow you to make decisions and repeat actions in your code. The most common control flow statements are if statements and loops. So for if statements, here's an example. Let's create a number and give it a value of 10. We're going to create an if statement that says, if my number is greater than 5, tell me that it's greater than 5. Otherwise, tell me that it's less than 5. If number, and then to do greater, we use the greater than symbol, is 5, and then I'm going to print number is greater than 5. Now, otherwise, else, I'm going to print that my number is 5 or less. Let's see what happens. The number is greater than 5. Now if I change this to 3, the else will get executed. To do a for loop, we type for, and then the syntax can vary, but in our example we're going to do I in range 5. Print I. What this is going to do is it's going to print 0, 1, 2, 3, 4, up to 5. Let's run our code. 0, 1, 2, 3, 4. Now, let's try the while loop. Let's define an initial value of 0. While count is less than 5. Print count. And what we're going to do is we're going to add 1 to the count every single time. Now what's going on here with this code? When we execute this, it's going to print our current value of count. It'll start here, and it'll go down, and it'll print this value, and then this thing here is going to change our variable to add 1 to it. So first time we run this, it'll print 0, then it adds 1, so this 0 then becomes a 1. Then when it runs again, it'll print 1, and then it'll add 1 to that, make that 2, and so on and so forth. Now, the while statement will keep this loop going while the value of count is less than 5. So once count reaches 5, it'll stop. So we should get 0, 1, 2, 3, 4, just like we had in the last example. Let's run this. Now, let's talk about functions. Functions allow you to define behavior, which you can then call repeatedly. So first of all, let's define a function. So to define a function, you always type def. We're going to create a function that adds two numbers together. So let's call it add numbers. we're going to give this function an A and a B as inputs. And what we're going to do is we're going to return A and B. Now, spacing in Python is very important. In Thonny, when we enter a new line under a function, it automatically creates these 4 blank spaces. You can also use tabs, but make sure you're consistent between whether you use 4 spaces for a 1 tab. If we didn't have our space here, the function wouldn't run. Now we want to call this function. To call a function, we can create the variable that we want equals numbers, and let's give it 5 and 3. Now we print the result. When we run this, we should get 8. There we go. What's going on here? So the return statement is basically giving us this when we ask for the function. So what we're doing here is we're creating a new variable called result. Then we're calling this function called add numbers, which we've defined higher up here. The 5 and the 3 are passed into these spaces of A and B. The sequence does matter. So if we put the 3 here and the 5 there, the A would be the 3 and the B would be the 5. Inconsequential for this example, but significant for other functions where it's important that you put the right thing in. You can even, if you want to be very specific, you can say A equals 3 and B equals 5. That will run just as well. Let's have a look at scope and lifetime of variables. So variables that are defined inside a function are local to that function, which basically means that they can't be accessed outside it. So this is known as scope. The lifetime of these variables is only as long as the function that is executing. So for example, if we take a function that basically just prints the value of x, which is defined as 10, what we can do is we can call my function here. We get a value of 10. But if we want to access x, like so, and then we run that, we get an error. Name error, x is not defined. That's because when we call my function, it creates x, and then it prints x, and then at the end of the function, it cleans this up out of the memory, so it no longer exists. This is so that Python remains memory efficient, but it also protects your code from using variables that are created within functions. So x equals 10 within the function can only be accessed when calling that function. But if we define y equals 12, we can print y. So variables defined outside of a function can be accessed anywhere in the script below where they were defined. Variables within the function can only be accessed by calling the function, and then they disappear at the end of that function. Let's talk about importing and using modules. So modules are basically files containing Python code that you can import and you can use in your own code. Python has a huge standard library of modules for various tasks, from mathematical operations to file handling. So let's first look at some of these standard modules that are included with Python. First of all, let's look at something called the math module. To import a module in Python, you type the following syntax: import and math. To use some functions from the math module, you then, for example, we can do the square root of something with this, square root of 16. And let's print that. Okay, run our code, we'll get 4. Great. It also contains the value of pi, as an example, 3.14, etc., etc. Now, you can import specific functions from a module too. So this is quite useful if you have if you know that you're just going to use, say, the square root or the pi. You can do from math import square root, comma, pi. We can write similar code to what we've just written here. So I'm just going to paste this below. Because we've actually imported these functions specifically, we can get rid of the math part here. And we can just do square root 16 and pi. And if we run that, we get the same. So importing specific functions from your module is useful because A, it saves on the amount of stuff that's loaded in. If you just import modules in their entirety, sometimes a module can be pretty vast, it can contain lots of functions, so this is a bit quicker. You can also give things custom names. So if we didn't like our sqrt, we can type from maths, import sqrt as, and then give it a custom name, square root. And then I replace my sqrt, square root, and I can run that. And we get our value there of 4. Great, so let's now work with some data. So the first thing that I want to introduce you to is NumPy. Now NumPy is a module that we can import by typing import NumPy. It's a powerful library for numerical computation. It provides support for arrays, matrices, many mathematical functions. Let's just start with a simple example of creating a NumPy array. So generally the syntax that we use is when we're importing NumPy is you import NumPy as NP. So you remember in the last what we just saw how you can give it a specific name. So let's create a NumPy array. NumPy dot array, and then like we define a list and create it like this. Print, and then we can access our array like so. All I'm doing here is just giving some text to show this is the array. So there's my array. Now it looks basically like a list, but the beauty with arrays is we can perform some basic operations on them. We can do our sum with numpy.sum. We can do the mean. And we can do the standard deviation. Okay, then when we run that, we get our sum, our mean, and our standard deviation of the data in that array. Now, the other beauty of arrays is that we can create two-dimensional matrices. Let's define a matrix. You type np.array as before, and that has to exist within circular brackets. But then we're going to create a matrix. So square brackets, and then another square brackets, 1, 2, 3, and then another square brackets, 4, 5, 6. This is a two-dimensional matrix. Don't forget that you have 2 square brackets at the end to close this. Now we can print our matrix. There we go. Operations that you can do, such as transposing or matrix multiplication. So let's try transposing first. To transpose, we type np.transpose matrix. Make sure we close our brackets properly at the end. There we go. Another way of transposing a matrix is to simply type matrix dot t. To multiply 2 matrices together, we can use numpy dot dot, and then we have to provide 2 matrices. So let's provide our matrix, our basic one, and then our transposed matrix. Those are brackets, run the code, and we get our multiplied matrix. Let's now talk about pandas. No, not the fluffy kind, the library. So pandas is a powerful library for all kinds of data manipulation and analysis. It provides data structures like series and data frame to handle and analyze data efficiently. So let's see how we can use pandas to read data from a file and perform some basic data manipulation. Pandas doesn't come with Python natively. It's an external package. What that means is when I try to import it, I'll get an error. Module not found. There's no module named pandas. So what we need to do to install the module is we go up to Tools, Manage Packages. Then in this search bar here, type the library that we want to install. in this case pandas, and then press enter. So we find pandas here, so we just click on it and then we click install. So this will just do some installing like so, and then once it's installed you'll see pandas here and it's listed down the left hand side. So let's close that, and now when we run our script here we won't get an error message. The general syntax when we're using it is normally importing pandas as PD. Don't ask why. I guess PD is just short for pandas, a bit like NumPy shortens to NP. Let's just say I have some data that looks like this. Numbers between 0 and 20, and I've got 19 rows of data. What I've done is I've just downloaded this as a CSV from Google Sheets. What you can do is you can use pandas to read your CSV file straight into Python. Just before running any code, I just need to make sure that my data.csv file, or whatever we call our CSV file, is in the same folder as the script which we have here. I've saved this one as pandas code. To read a CSV file, CSV data, we just type this, read CSV, and then we give the name of the CSV file, and we can print this data. There we go. So down the left hand side, these are just the indexes, and then we've got our data here down the right hand side. There's other useful things that you can do, such as typing CSV data.head, which just gives you the top results. It just gives you the first 5 rows of data. This is really useful if you have a big data file and you don't want to inspect all of it. You can also type tail to see the back of that data and see our last 5 rows of data here. Other properties that you can access the columns which doesn't involve circular brackets, so you can see the columns that we have. We just have one column called data, and then we can do some summary statistics. So we can data.describe, and that gives us a whole bunch of summary statistics here. Got our count, our number of rows of data here, calculates our mean, our standard deviation, our minimum 25th percentile, our median, our 75th percentile, and our maximum value. We can also select specific values within the data. We want our data column. We can select that by basically specifying the column name. Like so. That's called CSV data. And then we can print data column. There we go. We can also filter data. Like so. We take our filtered data, and what you do for this is you're saying, I want the data where it's greater than 5 from this specific column. So first of all, within, always square brackets, within our CSV data, we define our column that we're interested in. So that's this part here. And we're saying that within our CSV data overall. And crucially here, what we're going to specify is greater than 5. Close our square brackets. This is saying, return me from my CSV data file values in this column are greater than 5. And then when we print that, we get all of the values where the data is greater than 5. If we want to know how many values are there, we can type the length, len. That gives us the length of the data. 12 values greater than 5. Now let's have a look at some simple data visualization with matplotlib. So matplotlib is a popular library. Here's the website. It gives you the ability to create a whole bunch of different kinds of data. So you have statistical distributions here, gridded data, irregularly gridded data, 3D volumetric data. It's a very powerful, flexible library. It's very similar to MATLAB, if you've used MATLAB in the past. Let's see how to create a simple plot using matplotlib. First of all, we have to install the matplotlib library, if we haven't done so already. So we search for our matplotlib library, we click on it, and we click install. Great, so that's installed now. So we can close this. Basic syntax for using matplotlib is generally to import matplotlib.pyplot as plot. So we end up just using this plot thing, and that accesses the core plotting functionality within matplotlib, which is this pyplot function. So let's create some data. So we're going to create a variable called x. We're going to use this thing called the numpy linspace. method, and what this does is we basically create a set of evenly spaced numbers. So we say we're going to start at 0, we're going to finish at 10, and I want 100 numbers, please. So if I just show you this data in the terminal now, here we go, so it finishes at 10 and we've got 100 numbers evenly spaced between 0 and 10. Great. So now I want to create another variable. Let's say our variable is called y, and I just want to make that the sine of x. Okay. So y is going to take every single value in x and calculate the sine of x. Now I want to plot my data. To plot the data, I then do this sequence. I can type plot, and I want x and y, and my label is going to be sine x. This will create a basic plot of the x data, the y data, and I can give the axes names. So I can say plot dot x label is called the x axis, and give the plot a title, sine wave. Let's make sure there's a legend on the plot, so use plot.legend, and then finally to see the plot I type plot.show. Then when I run that code, I get my sine wave. X-axis is labelled on the x-axis here, my y-axis is labelled on the y-axis here, my title has been put up here, and my legend has appeared, and then the plot show means that the figure is here. There's a few buttons down here. You can reset the original view, go back or forward, you can pan around the plot, you can zoom in to specific areas of the plot. So let's say I really just want to zoom in here. Okay, great. Let's apply what we've learned now to a real world example. So we're going to simulate some population growth using a simple mathematical model called a logistic growth model. First of all, let's just set up our initial parameters and import the necessary libraries. So I'm going to use NumPy and matplotlib for this. So I import NumPy as NP, I import matplotlib.pyplot as PLT. I'm going to define some initial parameters for my model. So I'm going to define an initial population. I'm going to give that a value of 10. I'm going to define a carrying capacity. This is basically the maximum that the population can reach. I'm going to define growth rate of 0.1, and I'm going to say I want 100 time steps. Okay, so what we've done is we've imported our libraries that we need. We've defined some of our initial parameters in our model. So let's actually import the logistic growth model. I want to first of all say that my population is just a series of zeros, depending on how many simulation steps we have. That's my initial population. And my first time step, I'm setting an initial population to 10. What I'm going to do is I'm going to, rather than writing this out, I'm just going to copy paste my formula for the model in. So here's my model. So for t in range from 1 up until time step, so I'm basically saying for every time step that I have, 1 being the first time step after this initialization, my population at that time step is equal to the population of the previous time step, t minus 1 here, plus the growth rate multiplied by the population at the previous time step multiplied by this formula, 1 minus the population at the previous time step over the carrying capacity. Python follows the BIDMAS rules, so brackets, indices, multiplication, addition, subtraction, so these will be carried out in the correct sequence mathematically. And finally, let's plot the results. Again, I'm not going to type this out, I'm just going to paste similarly to what we had before. So we're going to plot the population, and we're going to give it a label, the population. My X label is time, my Y label is population, my title is the population growth simulation. I'm going to plot my legend, and I'm going to actually show the plot itself. So let's run this current script. So there's the results. So in this simulation we can see how the population grows rapidly at first, and then it levels off as it approaches the carrying capacity. So this is typical behavior observed in many natural populations. But you can play around with the initial parameters, and you can explore different growth scenarios and understand how factors like the growth rate and the carrying capacity affect population dynamics. So to continue this journey in Python, I've got some recommendations for you. So first of all, you can head over to my website at teach'em.digital, and there's a massive online community. Use your search engine liberally, check out documentation for the different libraries that you use. For example, if you're using the SymPy library for doing simulations in Python, you can go onto the website. And the key with learning Python is practice. So experiment with some of the examples that we've covered, try out new projects, don't be afraid to make mistakes. As you become more comfortable with Python and you explore advanced topics like machine learning or data science or automation, just remember that practice makes perfect, and the possibilities are really endless, and Python has a vast ecosystem of libraries, huge community, and kind of all the tools that you need to support your learning and go forward. So thank you for joining me in this Python crash course. If you've got any questions at all, or you need any kind of further clarification, don't hesitate to reach out. I'll do my best to answer all of your questions. Also, let me know if there are any specific topics that you want me to cover in any future videos. Don't forget to like, subscribe to the channel, and hit the notification bell so you don't miss out on anything else. So, happy coding!